Okay, hello and welcome. We're going to be talking about the area and the perimeter of quadrilaterals and of triangles. So four-sided and three-sided figures. So first thing is perimeter. The length around the exterior of a figure, pardon me, is going to be the perimeter. And so we're looking to find the length. Some kids make mistakes and are like, oh, I'm going to include some of the interior measurements like height when I do perimeter, but that is a problem. We only want to find the length around the exterior of a figure. So be careful when you're trying to do that. And every figure has a perimeter. If it's a circular object, we call that circumference. And then it's measured in linear units. So if you jog around the gym, you're going to say, oh, I ran 2 miles in the gym. That would be rather tedious because it'd involve a lot of laps. But running around the exterior of a figure will give you miles or inches or feet or however you would like to measure how far you have gone. And so there's some formulas for certain figures, but sometimes you can just add up the segment lengths around a shape. And so the perimeter of a rectangle, 2 sides that match each other and then 2 other sides who also match each other. So if you take one length and double it, and then you take the other length and then you double it, you're going to get the perimeter of a rectangle. You could just add up all 4 sides as well. And that's especially true if you have, say, a trapezoid or a figure that has 4 sides, but none of them match each other. So the perimeter of a square, since all 4 match each other, you could just take one side and then times it by 4. But those are kind of self-explanatory, and those are shortcuts you can choose to take or not take. It's kind of up to you on those. So that would be perimeters. Just measure the distance around a shape, and the answer will be in feet or inches or yards or miles or however you'd like to measure the distance that you've gone around a figure. Okay, to find the area, the definition of that is going to be the area of a closed plane figure is going to be how many square units will exactly cover the interior of that figure. And so if you look at graph paper, sometimes you can count the little squares within a shape, and that will tell you how many square units are within a figure. So, but we don't often graph, but we can look at. Okay, and so the background of that I'm using today is really actually kind of good for this topic, because you could just say, well, how many squares are going to be included in this figure? So you could kind of count them. You're like, oh, look, this is 1, 2, 3, 4, 5 across, and 1, 2, 3, 4, 5 down. So that means there's 25 squares within this figure. So you can do base times height, or if it's a square, you're going to just times the 2 sides together, and that would help you count up how many little squares are inside of this figure. Okay, and so and non-overlapping squares within a figure. So if you had more of a rectangular shape and you said it was 2 down, and say it was, say, 3 across, there would be 2 this way and 3 this way. So if you counted up all the little squares within that figure, there are 6. So base times height is a really good thing for most figures. A triangle, though, as you know, is just half of that figure. So you do base times height and then take half of it. And so that will help you with triangles. Trapezoids, because they have 2 different bases, you average them and you times them by the height. And so let's look at these figures right over here. Okay. So if you want to count up how many square units are within a figure, we'll count up how many square units would go across the bottom. Okay, count up that, and then count up how many square units would go vertically, and then multiply those units together, and that will give you the area. So if it was like, say, 8 across the bottom and 5 across the vertical, 8 times 5 would be 40 squares would be within that figure. So area is how many square units fit within that shape. And so base times height is a rectangle, side times side, or base times height is the same for a square. In a parallelogram, you can rearrange a parallelogram, and there's a kind of a showing of that down here. It really is the base times height, because what you can do is take off this corner and place it over here, okay, as shown in this figure right here. And so it really is base times height. So every parallelogram can be restructured by cutting off the triangle at one side and moving it to the other side, and it makes it into an exact rectangle. And this always is the case. So a parallelogram really is a rectangle, and it's just all you have to do is rearrange it to see that, yeah, it is the base and it is times the height. A triangle, whether it's going to be a right triangle or any other triangle, is actually just base times height and then divide by 2. The easiest way to see that is if you've got a rectangle, and if you say, well, base times height will give us the whole area, but base times height divided by 2 will give us the area for any triangle. So here's a good example of base times height over 2. That would also work for this. Base times height over 2. You can, some kids do 1/2 times base times height. You could multiply the base and height and then take half of it, or just take half of one of the dimensions and then times it by the other one. So never, ever, ever take half of both dimensions and then multiply them. That would be too much. You can do multiply base times height and then take half of it. How you multiply 3 numbers in a row is you multiply 2 together and then take that result, and then you can multiply it by the other one. So that's always how you multiply 3 numbers in a row. And a half is really a value, a number. And so you can multiply the base times height and then times it by half, or do half of the base and times it by the height, etc. For trapezoids, you're going to add up the 2 bases and divide by 2. That takes their average of the bases. And then, so that will give you the average base, and you times it by the height. So it really is base times height. And then for a rhombus or a kite, you actually have 2 formulas. A rhombus will work with a parallelogram where you do base times height. So you can use that for a rhombus as well, or parallelogram. And a rhombus or a kite also does the length of each diagonal who are perpendicular to each other. Find that product and divide it by 2. Okay, so a kite has to be used with that. A rhombus could be used with either the parallelogram one or the kite formula. So both of those work for rhombuses, but a kite has to do this one right here. Okay, so you could do. So let's practice. So let's find the perimeter of each of these shapes, and also let's find their areas. And so if you do the perimeter, we need the length of all 4 sides. And notice this is a parallelogram, so opposite sides will be congruent and parallel. To find the length of the slanted side here, we are going to need to do the Pythagorean theorem. So if we do 24 squared plus 7 squared, we'll get c squared. I'm going to take 24 squared plus 7 squared equals 625. So 625 equals c squared. Take the square root of that, and that's going to be 25. So that means the slanty length is 25. Since it's a parallelogram, opposite sides are congruent. That means these 2 opposite sides are congruent, so that's 23. So if you would like to find the perimeter of said shape, you've got to just add up all 4 sides. So 23 plus 23 plus 25 plus 25 again. If you put that in your calculator, yeah, you could double 23 and add it to double 25. That will give you the same answer. So we get 50 plus 46, and that will give us our perimeter to be 96, and that's in feet. So the perimeter equals 96 feet. Okay, so add up all 4 sides, or since you know 2 match, you could double one and then double the other and then add them together. So that'll work too. To find the area, we need the base and the height. Remember, a height must be perpendicular to the base. So a lot of kids don't really know which height to use. They're like, do I use 25? I'm like, no. Is that perpendicular to the base? No. So the base in this case is 23. So to find the area, we're going to do the base times the height, and they must be perpendicular. The base is 23. The value that is perpendicular to it to show the exact height of the figure from the lowest point to the highest point, perpendicular to the lowest point, is going to be 24. So if you do 23 times 24, you're going to get 552, and that's going to be feet squared. Okay, so base and then height, and they have to be perpendicular. So sometimes you have to reach outside the figure to find that the height as well. Okay, the next one would be, we got to find the perimeter. We know 2 out of 3 sides of this shape. So this side is 41, this side is 19. We do need to find that third side. They set us up with the Pythagorean theorem like a champion. So we're going to do 27 squared plus 30 squared equals c squared, and then we'll take the square root. I don't think it's going to turn out very cute. So if I do 27 squared plus 30 squared, I'm going to get 1629. If I take the square root of that answer, I get the c value to be approximately 40.36. It says round to the nearest tenth. So we're going to add the 2 sides we know, which would be 19, and we're going to add to it also 41. So if I add 40.4 plus 19 plus 41, and I'm going to get 100.36. So 100.4, and that's going to be in inches. Now, I notice there's a ton of dimensions shown, but we're just walking around the exact figure. So some of those auxiliary lines that are kind of extra lines to help us figure the remaining dimensions of the shape are not going to be included in the perimeter, because if you walk around the exact blue shape that's shown, the 3 dimensions you need would be the length of this black line and those other 2 green ones added together. And then to find the area, we need the base times the height. So we can pick any side as the base as long as we know the height of the figure from that perspective. And so I don't know the height from 41's perspective, and there's not really an easy way to find it. I don't know, but I do know the height if 19 is our base. I know the height of the figure is actually going to be 30. Okay, and so from the base, perpendicular to base, the base, and then also from the lowest point to the highest point of that figure is going to be 30. So you could do area is equal to 1/2 times 19. We're going to call that our base. The height that's perpendicular to it is going to be 30. So if I find the product of those 3 numbers, 0.5 times 19 times 30, I can put that on my calculator. I'm going to get 285, and that's in inches squared. Okay, so I think the big thing is pick one side to be the base of a triangle. Okay, so if I redraw this, you'll kind of see like a leaning triangle, and the base of it is going to be this side right here. And then the height will be the distance from that lowest point of the base up to the tippity top part of that base. And it's got to be perpendicular to that base right there. So it's kind of an awkward figure. We're really accustomed to seeing triangles like this, where the base is this part right here and the height would be inside the figure. But if you have an obtuse angle, the height from that base's perspective will be exterior to that figure. So if you have a right triangle, remember the base and the height can be the legs. Okay, the base could be the bottom, and the height will be perpendicular to it. So the legs are going to be the base and the height of a right triangle. So there are multiple ways to rotate a triangle. Pick one to be the base, and the height must be perpendicular to that base, and it must go from the lowest to the highest point from that perspective. So we'll get some more practice. And then the next side is going to be us finding some areas of these shapes. So this is going to be a kite. And so actually this is a rhombus, it looks like. So we'll see. We're going to find the length of the longer diagonal and the length of the shorter diagonal, and we're going to find their product and take half of it. So 1/2. The longer radius or longer diameter is 14. The shorter diameter is 12. If you find the product of those 3 items, 1/2 times 14 times 12, we're going to get 84, and that's in millimeters squared. Okay, so multiply those 3 numbers together. This triangle here, we're going to choose this length right here of the figure to be the base. The height will be the distance perpendicular to it from the lowest to highest point there. We don't know that yet, so we got to do the Pythagorean theorem. So 6 squared plus x squared equals 13 squared. Subtract 6 squared from both sides, and then take the square root. What am I going to get? I'm going to go in my calculator push, type 13 squared minus 6 squared, and then I get 133. I'm going to do the square root of that, and I'm going to get 11.53. So that's going to be the height here. And we've got to do 1/2 times the base, who is 29, times the height, which is 11.53, ... I'm going to just use that whole digit. So I'm going to do 0.5 times 29 times second answer, and I'm going to get 167.22. That's in centimeters squared. So if you find a dimension within a shape and you're going to use it to keep going, keep all the digits, use second answer as you need to, or grab it with your calc so that you can not round off until the final step. Okay, the next one, we need to find the area of a trapezoid. We need the length of one base, and the bases are parallel, so this is a base. And then this base right here, we know that this first part is 2. The middle part, if you drop this, is 19 because it's a rectangle. And then this part is going to be 10. So that's going to give us 20. So it's going to give us 31 inches is the entire bottom. And so we're going to do, to find the area, we're going to do area equals 1/2. We're going to do the bases added. So we're going to do 19 plus 31. And then we're going to times it by the height, which is perpendicular, which is 20 inches. Actually, I shouldn't label it yet, but when we're done, we'll label it inches squared. So we're going to do 1/2 times 19 plus 31, and then times 20. And that will give us our answer of 500 inches squared. Okay. So I think the big thing is remembering if you have a rectangle, opposite sides match. Also remembering that the bases are the parallel sides. For a kite, make sure you know a kite or a rhombus. One option is to do multiplying the two diagonals and then dividing by 2. So it gives us the area, and we're supposed to solve it to find the length of the missing diagonal. So let's practice solving. So if the area, which is 92, equals 1/2 times base 1 times base 2. So base 1 is 22. Base 2 is going to be x. Okay, so one option is let's just take half of 22. Okay, and so you get 92 is equal to 11x. And so 92 is equal to 11x. Because we can multiply half of 22, and that's 11. Divide 92 by 11, and you get 8.363636. So x is approximately 8.36, and that would be inches. Okay. The next one says, hey, I see a trapezoid, and I'm missing one of the bases. So the formula for the trapezoid is 177. The area of the shape is equal to 1/2. We got to do base 1 plus base 2. So we got 11 plus x. And then we've got to times the height. Okay, so you're like, how would we do this? Well, one thing we can do is multiply both sides by 2. Okay, so if you double 177, you get 354. So you get 354. So I wanted to get rid of the 1/2, so I'm going to times both sides by 2. Equals 13, and then x plus 11. Okay, I just kind of rearranged the inside the parentheses, and I just brought the 13 times the parentheses to the front. So one option is to distribute. Another option is to divide both sides by 13. You might be more comfortable with distributing. Okay, so if you do 354 is equal to 13x plus 13 times 11, get 143. Subtract 143 from both sides. You get 211. 211 is equal to 13x. Divide both sides by 13. And you're going to get 16.23 for your answer, approximately. And that's in centimeters. So we're just kind of trying to solve it. And there are sometimes multiple ways to do it, but this is a pretty straightforward way to say, hey, I see a half times a whole bunch of stuff. Let's multiply both sides by 2 to get rid of it, because the reciprocal, multiplying both sides by the reciprocal will get rid of that fraction. Half of 2 is just 1. So when I multiply the side by 2, it gets rid of that. But if I multiply one side by 2, you have to multiply the other side by 2 as well. Okay, so the next one, and these are pretty good algebra skills. Okay, so if you're feeling a little bit weird about this, we certainly can talk about, like, hey, can we talk privately about this? Yes. This is a parallelogram. The formula is base times height equals the area. So 148 equals the base 8 times the height x. If you want to solve it, you divide both sides by 8. X is going to be equal to 18.5, and that's in meters. So set the area equal to the formula and plug in what you know, solve for what you don't. The next one, they give you a triangle, they give you the base, and they don't know the height. So 357 is equal to 1/2 times the base, which is 34, and then times the height. Now, sometimes people like it to write it like this: 357 equals the base times the height over 2. Okay, so, you've got a couple options. You could divide 34 by 2. Okay, it makes 17x. Or you could say, okay, I don't like the fraction. Let's multiply both sides by 2. So you can multiply that side by 2 and multiply this side by 2. So you'll get the same answers. There's just sometimes multiple ways to look at it. So you could do 2 times 357. You get 714 is equal to 34x. Divide both sides by 34, and you're going to get 21. That's your height. If you had looked at it from the beginning and said, okay, I don't know about this, you could say, okay, well, 357 equals 1/2 times base times height. Well, half of 34 is 17x. That equals 357. From this point, half of 34 is 17. Divide both sides by 17. 357 divided by 17 gives you 21 straight there. So sometimes there's a couple ways to look at it. In my opinion, at this point, I would just take half of 34 and then divide both sides by 17. So it's up to you how you want to think about it. If you wonder, if you've thought of a different way and you want to talk about, like, is it the right answer? Well, you can try it, see if you get the right answer. You can also talk to me and say, hey, would this work as well? Okay, because there's some things, like, I think that'd be great, and it doesn't. There's a reason why it doesn't work. So we can chat if you'd like to. Okay, the next one says, find the area of the shaded region. There are a couple ways to figure this as well. If it is a square, okay, you know that all 4 sides will be congruent. And it does not say, but the bigger shape is also a square. Okay, so what I originally thought to do would be, hey, let's find the shaded square. So if this is 8 right here, let me get a pen, not a marker. If that's 8 and that's 8, and if this is a right angle, this would be 8 root 2. Well, if this is a square, to find the area of the green square, you would do 8 root 2 times 8 root 2, and that product would give us the area. So you would do 64 square root of 2 times square root of 2 square root of 4, which is 2. You get 128, and that would be in centimeters squared. So that's one way to do it. Another way I was thinking we could do it would be if you wanted to, let me think what I saw. If you wanted to think about taking the area of the big square and minusing off the white parts, okay? If you find the area of the big square, okay, the big square would be the bottom is 16 and the side is 16. So you would do 16 squared. You have to minus off the white parts. Well, the white parts are comprised of little triangles, okay? And if you think about it, this little triangle down here is an 8 by 8 triangle. Well, this triangle up here is its other side. This is also like the other half. So like it kind of makes like a square. And so this would be an 8 by 8 square. And then if you looked at, say, this part here and this part right here, they also together would form So the blue part, these two blue triangles form an 8 by 8 square. The other part over here form an 8 by 8 square. So that would be 64 plus 64. So you could subtract off 64 and you could subtract off another 64 and you'd be left with just the green part. Well, guess what? This is 256. And if you subtract off 64 twice, guess what you get? 128 centimeters squared. So there's a couple ways to think about this. Take the big square and minus off the little white parts. Or you could say, let's just figure out what the dimensions of the green square are and then just find the area of that green square. The next one is a windshield that's a trapezoid of all shapes. Okay. So to find the area, we're going to do 72 plus 85, the parallel bases, and we're going to take half of that, and we're going to times it by the height. If you type that in your calc, you're going to get, let's see, I haven't done it yet. I'm going to do 0.5. I'm going to do parentheses 72 plus 85, parentheses, and then times 38. Oops, I did just times 8. How about if we take it times 38? And you get, a whopping 2983, and that's going to be inches squared. That's kind of a lot of square inches. How big is a square inch? Well, if an inch is like yay big, 1 inch by 1 inch, it's how many of those squares would be fit placing side by side across that glass, okay? And filling the entire figure without overlapping, okay? One diagonal of a rhombus, okay, so one diagonal is twice as long as the other diagonal. So this would be, the short one would just be x. The longer one would be 2 times x, okay, double as long as the other one. And I said the area is 169. Well, how do you find the area of a rhombus? Well, you take half of the product of those two diagonals, so 2x times x. Okay, well, what's that mean? That's 2x squared. If you want to do half of that, 1/2 of 2 is just x squared. And that equals 169. And that gives you x is equal to 13. When you square root both sides, that would be in millimeters. All right, so I kind of threw out some stuff here. We got some formulas going, and truthfully, you just kind of have to practice it and then check your answers, see if you have any questions about how I got to the answers. And likely either you misunderstood part of the formula, you misapplied like what kind of PEMDAS rules you're doing, or you just typed it wrong in your calc. So talk to me if you got any questions. Thank you so much. Have a good day.